Hello everyone, hope you are all doing good. My name is Suresh Kumar Gundala. I have around 17 plus years of experience in IT with major focus on enterprise architecture and designing distributed systems, APIs, and micro UI applications. Today, I'm going to talk to you about enhancing systems resilience and efficiency with microservices, practical applications, and its real world impact, and discover how microservices architecture reshapes distributed systems with real world application examples. So, during the whole talk, when you watch the video, please feel free to connect me in LinkedIn. You can search for my name, Kumar Gundala, and feel free to share your questions or discussion points. And I'm more than happy to talk to you. I'll try to put in as much content as I can with this presentation so that you can see how it is working and you can leverage the knowledge on your day-to-day software development activities. All right, let's jump on to the talk. So, microservices as an architectural style have revolutionized distributed systems, offering unparalleled flexibility and efficiency in today's fast-paced business landscape. Unlike traditional monolithic systems where all components are tightly integrated, when the service go down, the entire application will go down, thereby limiting access to the application as a whole. The customers will not be able to access the application at all since the entire service will go down. But microservices enable this division of functionalities into independent services, thereby fostering agility and innovation. And when a specific service is down, only the functionality related to that service will be affected, and the users can continue interacting with the application. And moreover, microservices offer unparalleled benefits for the developers and the technical teams that are involved in each of the microservices teams so that they can work in parallel in the different microservices teams that the developers are in. So today, we will delve into the transformative power of microservices, exploring their principles, design patterns, and implementation strategies. So, throughout the practical applications and compelling case studies, we will uncover how microservices empower companies to innovate, overcome challenges, and achieve business acceleration. Join me as we navigate the fascinating journey of enhancing system resilience and efficiency through the adoption of microservices. Let's move on to the second slide where we will talk about the microservices revolution. The rise of microservices has marked a transformative shift in how modern enterprises approach software architecture. With 74% of organizations now using microservices in production, it's clear that most of the companies like this approach and has moved beyond a trend and become a standard for scalable, efficient, and agile development. So the advantage of microservices is microservices break down large and complex applications into smaller, independently deployable services, thereby allowing teams to work on different components simultaneously without stepping on each other's code base. And one of the most compelling reasons that most of the companies are trying to adapt to microservices is the significant boost in the development speed. On an average, organizations report up to 35% increase in development velocity when compared to our traditional monolithic systems. In addition to speed, microservices also offer considerable cost-saving benefits. Enterprises have reported a 28% reduction in infrastructure costs after migrating to a microservices-based architecture. This is often achieved through more efficient resource utilization, better scalability, and the ability to tailor infrastructure more precisely to each service's needs. So the microservices revolution is not just a change in technology. It's a fundamental evolution in how teams collaborate, deploy, and maintain software. Let us delve into some of the core principles of microservices. At the heart of microservices architecture is the principle of service independence, which means that each microservice is designed to run as a self-contained unit managing its own processes and maintaining clear boundaries from other service. This separation enables teams to develop, test, and deploy individual services without interfering with others. Right? Another core principle is modularity, wherein rather than building a single massive application, microservices are organized around specific business capabilities. So each service represents a distinct function, such as user management, for example. And then typically in e-commerce, we have payment processing, where you can separate it as its own microservice, or an inventory tracking can be taken it into its own microservice. Another core principle of microservices architecture is the fault isolation. Since each service operates independently, failures are contained within that service alone and do not necessarily affect the rest of the system, right? This isolation improves overall system reliability and resilience, making it possible to identify or even troubleshoot and fix the problems without disrupting the entire applications, as I told in the beginning. Another core principle is the concept of loose coupling, where microservices communicate with each other through well-defined APIs, avoiding tight interdependencies, which makes it easier to replace or upgrade individual services without having to make widespread changes across your system. So loose coupling also allows teams to use different technologies or languages for different services, offering flexibility in choosing the right tools for the job. Apart from the basic four foundation principles that we spoke, we have few other concepts like decentralized data management, where each service typically owns its own data store. And we have scalability and autonomy, where each microservices can be independently scaled based on the demand for that specific microservice. We have DevOps and continuous delivery alignment, where each of the microservices can have its own DevOps pipeline using CI/CD practices. And we have observability and monitoring, where each of the teams can detect, diagnose, and resolve issues quickly, just in case if there are issues arise with these microservices. Let's move on to the next slide. We'll talk about some of the key design patterns. One of the most critical design pattern that we use in microservices is the circuit breaker pattern. Let's take an example of an electrical circuit breaker, where this pattern acts as a protective mechanism that halts calls to a failing service to prevent the failure from cascading throughout the system. Like when a service is unresponsive or repeatedly returns errors, the circuit breaker trips and redirects requests to fallback logic or error messages. And implementing the circuit breaker pattern can improve overall fault tolerance by up to 42%, which helps to maintain system stability even under a tremendous strain or maybe a partial outages in the system. All right. Another important pattern is the saga pattern, which is particularly useful for managing distributed transactions across multiple microservices. The saga pattern coordinates a series of local transactions with compensating actions in place in case any part of the process fails. This ensures data consistency, and it has been shown to reduce transaction failures by 37%, especially in environments with high concurrency or fluctuating loads, like in e-commerce web applications, where a lot of shoppers shop and have heavy loads on the web applications. Another important pattern is the API gateway pattern, which plays a central role in managing how clients interact with microservices. So rather than clients communicate with each individual service directly, the API gateway acts as a single entry point, which handles the routing to specific services. It can handle authentication. It can handle the rate limit and protocol translations. There are so many other features available in API gateway, right? With centralized handling like API gateway in place, Most of the organizations have reported up to 56% improvement in the request efficiency. Another important pattern is the containerization, which is another powerful pattern that supports the microservices to be packaged and deployed in its isolated containers. Typically, we use container tools like Docker and Kubernetes, which helps us to ensure consistency across environments. Implementing containerization leads to an improved resource utilization by up to 62%, as containers can be orchestrated dynamically based on the workload demand, right? Let's jump on to the next slide and we will talk about the business impact of microservices. The first one being development speed. So by breaking down applications into smaller independent services, development teams can work on different components simultaneously, reducing bottlenecks and accelerating the delivery of features to achieve faster time to market. Right? The companies leveraging microservices report a 35% increase in development velocity compared to the traditional monolithic architectures. Another one that we are going to talk about is the operational cost. With precise scaling and better resource utilization, businesses can optimize their infrastructure costs by better allocation of resources, with some of the organizations reporting even a 28% reduction in infrastructure costs after transitioning to microservices. As the scaling and resource utilization are much better in microservices, most of the organizations report a 28% reduction in the infrastructure costs. Another important aspect is the system scalability, where each of the service operates independently, allowing it to scale horizontally without impacting the rest of the system. The modular design of microservices ensures that systems remain flexible and capable of meeting user demands, no matter how complex or unpredictable it may be, right? Another important aspect is time to market. Traditional monolithic architectures often struggle with lengthy development cycles and deployment cycles, thereby making time to market of the product very slow. In contrast, microservices empower teams to implement changes, fix bugs, and deploy updates on its own. What does it mean by on its own is that each microservices has a responsible team, so they can fix bugs and deploy their updates much faster than a traditional monolithic application. The study shows that this leads to an improvement of 50% in the development time, which makes microservices to go to market quickly. Right? Let us move to the next slide where we'll talk about an e-commerce case study, which is one of the luxury retailer where they converted to microservices. So before adopting to microservices, this luxury retailer faced significant challenges stemming from its rigid monolithic architecture. Because of its inflexible system, it hindered innovation, preventing the company from responding quickly to the market demands. So deployment cycles were exceptionally long, taking almost up to 6 weeks to roll out new updates or features. Such delays not only impacted the time to market, but also limited the retailer's ability to stay competitive. Right? Additionally, the monolithic nature of the system made scaling very inefficient, as it required duplicating the entire application, which consumed the extensive resources and entire resources, as the entire application will be replicated to a separate node, which led to high infrastructure utilization, almost at 87%, resulting in performance bottlenecks. Once this retailer shifted to microservices, this really marked a turning point for the retailer. By breaking down the monolithic system into independent services, the company achieved remarkable flexibility and agility. The transformation enabled rapid innovation, empowering teams to implement new features more efficiently than a traditional monolithic application. Infrastructure utilization dropped from 87% to 42%, enabling the company to reduce operational costs by an impressive 35%. This efficient resource management ensured the retailer could handle high traffic volumes during peak shopping periods while maintaining a very good performance. These advancements really helped the retailer to strengthen its reputation as a leader in luxury e-commerce, thereby driving customer loyalty and increasing customer revenue. Let's move on to the next slide. We will talk about some of the implementation challenges. Transitioning to microservices architecture is a significant undertaking that requires addressing various organizational and technical challenges. One of the most critical obstacles is organizational change, which normally involves like restructuring teams and fostering a shift in culture, and then some learning curve. Right? Moving from monolithic structure to microservices demand decentralization where individual team takes ownership of specific services. Another challenge that I see is the service coordination. Like in a microservices ecosystem, each microservice operates independently, but they are interconnected, relying on each other to deliver a unified experience for users. Another challenge that I see is in the distributed testing. Unlike monolithic system, where testing is centralized and straightforward because the entire application is monolith and they can test the entire application, whereas microservices require testing across multiple independent services, these services interact in dynamic ways. Another challenge that I see is the technical complexity, which seems to be a major hurdle in implementing microservices, because configuration, management, deployment, and monitoring become exceptionally challenging as the number of microservices increases. Lastly, it's also vital to address the learning curve for teams transitioning to microservices, as most of the engineers and developers might have got accustomed to working in a specific monolithic style. These teams might find it challenging to adapt to the decentralized and the distributed nature of microservices. Here, let's move on to the next slide. We will talk about some of the observability strategies that we can use in microservices to ensure the smooth operation and maintain the resilience of microservices architecture. The metrics collection is a foundational strategy for observability, which enables the tracking of key performance indicators across all different microservices. Metrics like response times, error rates, and resource utilization provide a quantitative understanding of the system's performance. Another vital component of observability is distributed tracing, which provides a comprehensive view of how requests propagate through the service mesh. Distributed tracing helps us identify bottlenecks, the latency issues, and the service level failures by actually pinpointing the exact service or the component responsible for the errors, or you can say disruptions. Centralized logging is the one that enhances observability by aggregating all the logs from all the services into a single platform, right? Logs capture valuable information about events and errors. If you have centralized logging enabled, all of these logs can be aggregated and captured into a single platform, right? Thereby making troubleshooting easy. Another strategy is implementing proactive alerting. Proactive alerting basically enables teams to address potential issues before even it affects users, because developers can get automatic alerts when an error occurs in a specific microservices. Thereby, the developer can take a proactive step to identify the issue and then fix it. We will talk about testing excellency in this slide. As for any application, testing is the backbone to ensure the reliability and performance of the application. Even for the microservices, testing becomes the backbone to make sure the application is of a good quality. So we have strategies like unit testing, where it serves as the first layer of defense. By testing each service independently, developers can verify that its core logic functions work correctly without external dependencies. Right? This method increases the code coverage by almost 32%. Building on unit testing, integration testing basically verifies how services work together when they are deployed together as a whole to deliver seamless functionality. And integration testing checks the compatibility and correctness of communication protocols, data flows, and shared APIs between services. So it reduces integration bugs by almost 47%. Another strategy is the contract testing, which plays a vital role in maintaining API stability across microservices. Contract testing ensures that APIs remain compatible and fulfill agreed upon expectations between service providers and different consumers. This not only improves API stability by 56%, but also fosters trust and consistency within the service interactions. Another innovative testing approach is chaos state testing, which validates the system's resilience under adverse conditions. By intentionally introducing failures or disruptions, chaos testing evaluates how the system responds to unexpected challenges. This practice usually enhances the system reliability by around 38%. We will talk about some of the migration strategies in this slide. So migrating from a monolithic architecture to microservices is a strategic and also the complex process which requires careful planning and so the first step in this transition is decomposition analysis, which involves identifying bounded contexts within the existing monolith. By breaking down the monolith into these smaller and independent units, organizations can lay the groundwork for creating the microservices platform. Another widely used approach is the Strangler pattern, which allows for gradual and risk-minimized transition. Instead of attempting a complete system overhaul, the Strangler pattern involves replacing the specific functionalities of the monolith with microservices incrementally. So over the time, the monolith shrinks as more functionalities are being transitioned to microservices. Another approach that we can use is the pilot service. This approach involves identifying a non-critical service within the application that can serve as a test case for the migration. By starting small, teams can learn the nuances of deploying, managing, and monitoring microservices. Another key component of a successful migration strategy is developing a full ecosystem to support microservices. This involves setting up the necessary infrastructure, tools, and processes to manage the complexities of a distributed systems. And finally, the key takeaways. So the adoption of microservices architecture has revolutionized how businesses achieve acceleration and agility in their operations. So by breaking monolithic systems into smaller independent services, organizations have unlocked faster time to market and enhanced customer satisfaction. Microservices empower development teams to deliver features rapidly, often reducing delivery timelines by almost 45%. This capability not only helps businesses respond quickly to market trends, but also provides a significant competitive edge in dynamic industries, say for example, like an e-commerce. Critical takeaway is the ability of microservices to enable operational excellence through enhanced scalability and resilience. Traditional monolithic architectures often struggle to scale efficiently, especially under varying traffic loads, where, however, microservices allow for independent service scaling, optimizing resource utilization, and reducing operational costs by as much as 32%. Microservices also foster technical agility, allowing teams to innovate faster and adapt to changes seamlessly. With services operating independently, teams can experiment with new technologies, frameworks, and approaches without affecting the overall architecture. This flexibility translates to a 56% improvement in development velocity, enabling organizations to continuously innovate and stay ahead of the disruptions. So, in conclusion, microservices architecture is not just a technical framework. It's a paradigm shift that empowers organizations to achieve agility, resilience, and innovation in today's fast-paced world. So from transforming rigid systems to accelerating future delivery, microservices offer a strategic advantage that goes far beyond efficiency. As you have seen through practical applications and real-world case studies, microservices have the power to drive business acceleration, reduced operational costs, and improved customer experiences. So, with this, I encourage you all to take this opportunity to rethink how your systems are built and embrace the future of our distributed architecture. Let us all move forward together in leveraging microservices to create smarter, scalable, and more innovative systems that meet the demands of tomorrow. Right? I hope you like this content. Please feel free to leave your feedback by connecting to me in LinkedIn. Again, my name is Suresh Kumar Gundala. You can search for my name in LinkedIn and please connect to me if you have any questions. All right. On that note, thank you so much for your time and attention. You all have a wonderful day. See you guys. Bye bye.